Otherwise, you can leave it here in case someone wants to take it and walk around. So, great. Okay, can I please ask everyone to sit down so we can start? And maybe someone can close the door. Good. Then I welcome you all to the second part of our science session about consequences of permafrost changes in the Arctic. My name is Markus Englert. I'm from the Research Council of Norway, and I'm chairing this session. I wanted to start the session with a keynote talk by Tiffany Smith from the US Coast Guard Academy, but unfortunately she cannot come due to newly travel restrictions imposed by the US government. So we have to skip this first keynote. That means we have only 6 talks here in the second science session. We will start then with the second talk, and we will have time at the end. So we'll use the time at the end for questions where you can ask both for this session and also for the previous session. So for those speakers who are still here from the first session, please be prepared that there might be questions after this session. Then we move to our first talk to this session by Julie Mollefond-Lepage. She's a postdoctoral researcher at NTNU Trondheim, and she will talk about the challenges and key outcomes in building an international platform for permafrost internships. Please, Julie.
Perfect. Hi, everyone. So my presentation today will be on 2 projects, PermaIntern and Senna. They are both URT projects, and more specifically, I'll talk about the challenges and key outcome in building an international platform for permafrost internships. We are 4 members in the executive community, so there is myself as the leader of PermaIntern, there is Frédéric Bouchard as the leader of Senna, Anne Christiansen that was chairing our session this morning, and Ylva Schödberg from Umeå University. There are in total 15 partners that have been contributing to these 2 projects in the past 4 years. Those partners are from Europe, Canada, and even South America. So what was the goal of PermaIntern? It was to design and develop a permafrost internship service available to students, universities, and internship hosts, covering the full variety of permafrost working life activities from university research to engineering company work. It was initially funded by the Danish UArctic network from 2022 to more recently, end of December 2025. The program has been developed by the Nordic countries, and we started to collaborate with Senna, which is a Canadian UArctic project since 2024 to expand internationally the internship program. And PermaIntern is a very flexible program, so it's open for bachelor, master, and PhD students, and any employer with activities related to permafrost can join our program. It's also flexible in the way that there is no specific length for internships. It can be less than a month and up to several months. It can be paid or unpaid. And we really make sure in our program that we have certified supervisor with permafrost expertise that can help the students during their stay abroad. So why are permafrost internship important? Because most of students will never hear about permafrost during their university studies, and those that have an interest are really struggling to find a course to learn the basic knowledge of permafrost. So to give you an example, we did a mapping of all the permafrost courses in the Nordic countries, and we published a paper in 2024, so we have been doing that quite recently, and we found out that there was only 5 permafrost-specific courses on permafrost in all of the Nordic area. And since 2024, even some of those courses have been canceled, so it's even less than that at the moment. So with the internship program, we wanted to open a new way for students to get access to permafrost knowledge. And I wanted to come back to 3 important aspects of internships. They are very beneficial to strengthen the link between education and working life. They are important to realize permafrost competence beyond academia and to connect Arctic permafrost education and professionals. So we have been working hard on developing a web platform that has been running now for a year and a half. You can find it at permaintern.org, so I invite you to go and have a look, and I'll travel through the platform with you quite quickly during my presentation. So on the home page, it tells you how it works and how our program works and how to join the program. There's a section about SEGNAS, so it explains what is the Canadian New Arctic program about. You'll see the steering committee. There's a section for hosts and supervisors, so you'll find information about how to join, how to be certified, so you have to fill up a document with some questions about how internship work in your company or in your universities. And we make sure during the certification process that we have an online meeting with those interested, and that we discuss about how the program works and what are our expectations. There's students on internships, so that's where you can see all the internships offer. There's a section for students, so once the students have finished their internships, they have to write a blog post and we put them online, so it's a good source of inspiration for other students where they can see what kind of project or what kind of internship they can do. We also have some education material on permafrost. We have merged the frozen ground cartoons onto our platform. It's a project that started 10 years ago that developed different cartoons on permafrost, and those cartoons have been translated so far in 10 different languages. And there's a section on resources where we if you want to know about permafrost, we give important websites like the International Permafrost Association or the Permafrost Young Researcher Network website. And we have a section on news, so that's where we post in which conference we will be participating or when we are hosting open online webinar. So since 2023, we have supported 15 perma-intern trainees across 8 institutions in Europe and in the Americas. And we have provided more than 215,000 Norwegian kroner in travel support. To give you an idea, last fall we had one student from Argentina doing an internship in Sherbrooke in Canada. We had students from Vancouver traveling all the way to Switzerland. And I have currently at the moment students from Bangladesh doing a 5-month internship at NTNU in Trondheim. And we got very good comments from all parties, the students, the internship hosts, and the supervisors so far. So it has been a great success, and the internship hosts that had one internship or accepted to have one really asked quite rapidly for a second one. So on my side of view, they have been hesitating a little bit to participate because you don't know how much time that will take to have an intern. But at the end, you have to keep in mind that the students they do it on a voluntary basis, so they're super motivated, they're eager to learn. So it's it has. Our group has been really active in the past 4 years. We have carried out a lot of different activities to support the functionality and the sustainability of the program over time. So we had 3 workshops, 2 in Copenhagen, 1 in Puerceda, Spain during the European Permafrost Conference, where we invited the permafrost community. So we had 50 attendees, so we presented our program and we got a lot of constructive comments. From them, we had many online meetings where we discussed the platform content and functionality, the pedagogical challenges and opportunities, the certification processes, and of course the challenges related to international internships and so on. We launched officially the web platform at the International Conference of Permafrost in June 2024 in Whitehorse, Canada. So a year and a half ago approximately. We also participated in 10 conferences so far, and we held 3 open online seminars where 2 of them students presented about their internship experience, and one of them was a discussion between the internship hosts and supervisors about the benefit of the program, the challenges they encountered, and how we can improve the services. And we extracted recently, January, the data from our website regarding the last 2 years of the platform. So from January 2024 until December 2025. And like I said, we launched the website in June, so approximately here. And we have had so far visitors to our website weekly since the opening, and in total we had 1,800 guest visitors from 47 different countries. So yeah, the students are ready to go on internship. They are definitely answering our call. And you see below here the maps of all the different countries where people have logged on to our website. I wanted to discuss a bit about the challenges we encountered because we face mainly along the way. At the beginning of the project, it took us a long time to understand all the different internship programs across the universities in the Nordic countries. It's very different. For instance, in engineering, internship have been developed and running for several years, so they're well implemented. And in other science domain, it's either very limited or inexistent, meaning that students, they cannot do an internship and get credit for it. So we really had in mind to develop a program that is very flexible and open to everyone. And then we had challenges relating to internship being paid. When we started to open the program internationally, it was very evident that the internship could not be paid because the students would need to go through the immigration process to get a working permit, which takes a lot of time on all parties, and it's very expensive as well. So we really decided that the program was non-paid, but we will support the students with travel, mobility, and accommodation as well during their stay, and it has worked super well like this. And we also encountered a big challenge regarding to have companies involved. It's definitely, it has worked super well in universities so far and research center, but for companies, they really need to develop the internship many months in advance, for example, and sometimes the internship has to be paid, so it's illegal to have unpaid internship, so it was a bit complicated for them to have students coming from other countries. As well, there is a question of privacy of data. Some of the project, the data cannot be shared, so students cannot work on it. So yeah, many challenges, but we really hope that we can have more companies joining our program. And what's next? So we are going to have a closing workshop at the Arctic Science Summit in Aarhus at the end of March, where we'll discuss how to maintain financially years. And yeah, to conclude, Permafrost and Senna are definitely contributors in the educational on permafrost across the UArctic. And we really hope that the program can inspire other UArctic programs, that the program can go beyond permafrost science. And I wanted to finish by saying that we are always seeking new permafrost internship hosts. So please, if you, that would be just reach out to us if you are willing to have an intern. Thank you.
Thank you very much, Srili. Unfortunately, we ran out of time, but we have a lot of time after the session. So please keep your questions in mind. And now I ask Hanne Christiansen on the stage. Hanne Christiansen, she doesn't need an introduction, but still I mentioned that she's Arctic Chair in University of Arctic Chair in Physical Permafrost Processes and member of the University of Arctic Academy Advisory Board. She will give a talk about permafrost knowledge status in Longyearbyen, where she has been living for more than 20 years and chairing the permafrost section there. Please, Hanne, welcome.
Thank you very much. Yes, it's a pleasure to give you the basic of the status of permafrost physical knowledge in Longyearbyen. I'm going to tell you a little bit about this site. You could know, probably some of you, this better, but only 2,500 people call this home, but you can see that they're living in a valley with quite steep mountain sides. And the other interesting thing seen from a permafrost perspective is that the valley is infilled with sediment. And this combination with the fact that this is one of the hotspots of climate change in the Arctic as of now means that the permafrost can be really active up there. And what we recently saw when we had one of these warm spells in October 2016 was this, and that is active layer detachment sliding. So you can see on the top of the mountain here, we actually had the entire active layer being saturated, and it was sliding down all the way to here. This is the cemetery. It stopped 20 meters from the cemetery. Water still saturated the ground, and it kept running like this, and actually formed a sediment fan that crossed the road. So this is, of course, actually affecting the infrastructure in Longyearbyen. And by that time, I was thinking a lot about permafrost, working with it, but not in town, but outside town. But then we very, very quickly understood, okay, we have to also change our focus and actually work with the permafrost that we live on in Svalbard. And so we have been able to start working on what is actually inside the permafrost, because one thing is that it's frozen, but what does it contain? So we started having the possibility to build what you see here, a platform that can actually operate manually and take sediment cores or down to 4 or 5 meters in the permafrost. And you're seeing such a core here. Not so many people have seen permafrost, but that's why you need to drill to see what's actually in there. We also have we developed another infrastructure that's part of the SIRES infrastructure sitting at UNIS at the moment, a drill rig that can drill even deeper. And we use that in the central part of the valley where you need to go further down. That wasn't so successful. It was very challenging to drill there. We'll come back to why. But in the very challenging to drill there. We'll come back to why. But in the short cores that we obtained, we actually saw all. This is the name for all the different types of ice as it forms in permafrost. And you can see that it's everything from very normal looking sediments that hardly has ice content to different structures where you have clear layers of ice and where you can have a quite high ice content, almost 100%. And then you have also got what we call excess ice content. This means more ice in the sediment than the pore space allows. And when that happens, that really becomes an issue, because then, of course, when you start thawing the permafrost, you have a lot of water that can create mobility. So this is a distribution of some short ones and some deep ones, and those have been instrumented also with casing so that we can monitor the temperature, and we've done that for the last 3 years. I'm not going to talk about that in the short talks, but you can see that the active layer thickness is somewhere between 1.6 and 2.2 meters, so that's pretty deep. When we then look into what does it actually look like when we go into the ground, this is the results from our PhD student that has really analyzed all of these cores. So you can see when we're looking in these deep cores, these are the ones in the lower part of Longyearbyen, sorry. You can see that we are dealing with relatively coarse-grained sediments. This is why it's difficult to drill. And what you can also see is that there's not a lot of ground ice present in the top of these cores. There is also some dating going on, especially this one's very interesting, point here, where we can see that we have very, very quick sedimentation. So almost 20 meters within no time. And that's, of course, because we're sitting in a delta that shows that we've had sediment transport going on here. But then what about all the short boreholes? What do they actually tell us? That's the picture is a little bit different. We're still dealing with some kind of coarse-grained material, but you can see that we have much more ice content, especially when we come down to the top of the permafrost. See this one here? Almost no ice in the active layer, and whoops, we have lots of ice there. And all of these things put together actually allowed us to make the very, very first version of a ground ice map of Longyearbyen. And you're looking at it here. It has just been published 3 weeks ago, so not so many people have seen it yet. And this just shows you what is the content of ice in the top 1 meter. What is the excess ice content? So this additional ice, you could say. And you can see that there's not much going on in the valley bottom. There's much more ice in the mountain sides. This is, of course, important when you want to build. But there's something else that's also important. You also obtain when you drill deep, And that's the knowledge about how far down do I actually have to drill to encounter real rock wells. Not real rock in Longyearbyen, it's sedimentary bedrock. And you can see that that varies, but you can have, in some places, to drill 40 to 50 meters. And some people think that that's what is needed now to actually make foundations, but also on all the national databases for drilling. And so with establishing the avalanche defense structures, of course, a lot of data points also came up here. But you can clearly see how the valley is infilled with a lot of sediment. And this, of course, means that when you build, you have to build on something, and most of the housing is actually standing on what we call foots that sits inside the permafrost, doesn't reach to bedrock. And if you don't manage it well, of course, things can happen like this. So what we actually decided in our endeavor to actually understand better the permafrost is that now that these new buildings start popping up, you won't believe it, but students live on the 5th floor in Longyearbyen nowadays. That's the tallest buildings that has been built up there. And that's actually buildings that was put on piles that goes all the way to the rock. So more expensive than other way of building. We thought, okay, since there's the avalanche problems, people were removed from part of town, this area that sits down here in the flat part, the bottom, might be where the new expansion of town should happen. And we need to know more about that, because when we drilled the deep boreholes that I showed you before, we actually had a lot of problems doing that because we encountered water. Water in permafrost can happen. There is a hydrological system inside permafrost. But you don't want to build a whole part of town on something that you don't know if it's stable or not. So what we did is that we had luckily got some additional new funding that was possible to actually start studying this permafrost in the lower part of town. So this is what it looked like in December last year. And you can see that now we really put the heavy duty material into action. So this is the industry scale drill rig. And these are the guys that really know what they do. They had difficulties and they almost gave up twice, but we kept telling them this is important. So we managed to get 3 boreholes down to 40 meters. You can see one of them here. And actually we also managed to get it instrumented very, very quickly afterwards. And I'm going to share with you in the end here what is actually the inside of this. So you're the first ones that see this data. We have not looked in very large detail on that yet. But you can see that since the 6th of December, the drilling were done 1st and 2nd and 3rd of December. So instrumentation in the ground on the 6th of December. You can see that on the top, of course, we have the fluctuations of the air temperature. But when we go down to 10 to 40 meters here, you see the cooling that is still going on after drilling. And if we have just a temperature look last Monday, so a week ago, we can see what is actually the ground temperature all the way down. And that luckily shows us no positive temperatures. That would be the indication of fluent water, running water. But of course, this is just a snapshot, and this is just in the time of still cooling. So we will have to look further into this to really understand. And I should add that these semester strings are not the normal type where you kind of have increasing distance as you go down because the permafrost doesn't vary so much. But we're actually monitoring every second meter all the way down to catch if there's water inside the permafrost. So what do we do with all of this data? Well, if I had 10 more minutes, I could talk about that. I do not. So that will be another time, but we're developing a permafrost climate response system that collects all the data. And in the end, I want to say that this was not possible if we didn't have what we call UNI's strategic pilot funding, which was the first project where we did this research. And then at the moment, we're actually running a so-called collaborative project to meet societal and industry-related challenges. This we call Thawing Longyearbyen, and that is short for Thawing Arctic Permafrost Emerging Risks, so managing the critical infrastructure, cultural heritage, and mountain slopes under climate change. And I've overspent my time. Thank you.
Thank you very much, Hanne, and keep your questions for after the session. For our next talk, we have 2 presenters. We have Ratna and Christina. Ratna is an assistant professor at the Sami University of Applied Sciences, and welcome. And Christina, a cartographer at Woodsville Climate Research Center. And today they will talk about navigating the new Arctic, the uncertain future of reindeer herding. Welcome.
Kiitos, Bore Päivi. Good day, everyone. My name is Rauna Maria Eira Sara. I'm a Sami reindeer owner from a reindeer herding district named Fala. And our SIDA is a partner of the JEF, UNEP Reindeer Herding and Resilience Project, which is initiated by the International Center of Reindeer Husbandry. As you said, I also work as a teacher and researcher at Sami Allaskola, Sami University of Applied Sciences in Gårdegay. She can present herself.
Hi, I'm Christina Shintani, and I'm a cartographer at Woodwell Climate Research Center.
So thank you very much for giving us the opportunity to present our collaboration on a map that shows MySIDA's migration routes, pasture use, seasonal pastures, and also encroachments and developments in our reindeer herding pastures. So I find our title very fitting because reindeer husbandry all over the Arctic is facing a lot of challenges nowadays. So it's fitting. So, indigenous knowledge, and in our case, Sami reindeer herders' knowledge, is the foundation of our livelihood and our sustainable reindeer husbandry. This knowledge is the basis for reindeer herding, and these pictures show you a little bit of my life at our SIDA. So the importance of knowledge transmission from elders to children is one of the keystones of the survival of reindeer husbandry. In our everyday life today, we have one foot in the modern way of life and the other in a traditional Sami way of life. So over time, these two ways of living have merged into one system where we balance the traditional way of life with the demands of the other. So reindeer pastoralism is a traditional form of semi-nomadic herding practiced across the Arctic and the subarctic regions. It's a distinctive example of sustainable land use in extreme northern environments and is deeply intertwined with indigenous knowledge. So there are at least 24 indigenous groups that in the Arctic that are reindeer herding peoples, and they are herding approximately 2.5 million reindeer. So those permafrost is sporadic in my area in Finnmark, here in northern Norway. It overlaps with the reindeer husbandry across most of the Arctic, as you can see of this map. Permafrost thaw and a warming climate are driving shrubification in valleys, and it's altering traditional migration routes, and reindeer herders are reporting on drying of pulsa mires, the peatland ecosystems. So the recent years, reindeer husbandry have experienced how climate change is impacting the nomadic livelihood. For example, the last winters we had extremely bad grazing conditions. So to draw this to my own research on Sami reindeer herders' food systems, what I do at Sami Allaskola, I see the change in the everyday diet of herders due to governance structures and ignorance of Sami reindeer herders' own food knowledge. So climate change and loss of pastures is impacting the Sami reindeer herders' food systems today. So let's look at the map. So here is the map that we have created together with the Woodwell Climate Research Center. And it shows our SIDA's seasonal migration between summer area in the coast and winter areas located inland. So this is an example of how a map is used to tell a story and educate others about the lag fragmentations and climate issues. It documents traditional knowledge, and it's also used as a medium to draw a broader audience. So Christina will continue after me to tell about the process of making this map. So this map is an important tool for our SIDA to present our view of reindeer herding. So our summer pastures are on an island with major industrial developments going on, and more are planned. So for instance, we have the LNG plant on Melkøya, operated by Equinor in the city of Hammerfest. In 5 years, it is estimated that 70% of the pasture on this island will be affected in some degree. Such bit-by-bit extraction of reindeer herding land annually decreases the daily economy and living conditions of reindeer herders. Therefore, I think such a map will showing the whole picture of the land fragmentations and other issues related to our SIDA will help explaining our situation. It gives an overview how we use the land, how our ancestors have been using this land, and at the same time it shows how globalization have impacted and taken land bit by bit because the Norwegian society demands it. So these land fragmentations in our areas, it equals loss of economy, it equals loss of traditional knowledge, loss of important pasture land, which again will impact our food systems, our health and well-being. So now I think it's time for Christina to tell more about the process of making this map.
Thank you. My colleagues went there about 2 summers ago, and Ravna and her husband showed them around their summer pastures, and where they could see the building firsthand, and just spend time with them to understand the issues. So meeting with people, putting maps on the table, of what makes co-production work and allows conversations. And without maps, the conversation wouldn't be as rich. So maps can be used for communication, not just at the end of a project, but also at the beginning. I won't go over the dozens of iterations that I made, but at the end, we ended here where the migration route goes from corner to corner, and the map walks you through the migration route and the issues that the reindeer and their herders face along the way. So who sees the map? What's the impact? Because your goal is to reach the broadest possible audience and the right audience. Last summer, we debuted the map at the largest geospatial conference in the world, and there were nearly 750 map submissions to the gallery, and our map won 3 of the awards. There were also some local media that covered it, along with maps.com. And so all of this great feedback is very appreciated, but why does that matter? I think the map did well because of the co-production process. When you combine beautiful cartography with a unique and important story, people can't help but be drawn in. So maps have a transformative power to help people understand and see something they may not have noticed in another medium. So when you're thinking about how to communicate your science, maps are a really powerful way to do that. So last week we held a mapping workshop with the Sami reindeer herders that went really well. And going forward, we'll do a similar workshop with Duha reindeer herders in Mongolia. So this QR code will take you to a digital version of the map if you're interested, and we also have the map in the map gallery if you're in the Saga Hotel if you want to see it in person. Thank you.
Thank you, Ratna and Christina, for this talk. And unfortunately, we don't have time for questions, but we will have time at the end. So we move on to our next speaker. Irene is already standing here, a doctor in Finland, and her research is about slope hazards. And today she will give us an overview of a geospatial modeling of permafrost thaw-induced landslide across the Arctic. Please,
Thank you. Hi, everyone. I am Irene Makopouliou, and I'm a PhD researcher at the University of Oulu in Finland. And today I'm going to present you my thesis in less than 10 minutes, hopefully. So my title is the Spatial Modeling of Permafrost Thaw-Induced Landslides Across the Arctic. And as we said already today, there is climate change and Arctic warming. Nearly, like Arctic has warmed nearly four times faster as the global average, and that leads in permafrost degradation, which in turn destabilizes landscapes, disrupts ecosystems, and releases trapped carbon dioxide and methane. Two of the nice outcomes of permafrost degradation, not nice in general, but nice for me because I'm studying them, are retrogressive thaw slumps and active layer detachment failures. These processes not only reshape landscapes, but pose risks to infrastructure and human activities. Okay, so we go with active layer detachment failures. ALDs are shallow translational landslides that occur when the active layer of thawed soil becomes unstable and detaches over still frozen permafrost. It can extend from several meters to over 100 meters downslope, and the sliding layer can usually be from half a meter to 3 meters thick. They're typically triggered during warm summers or heavy rainfall events, and are most common in ice-rich, unconsolidated slopes. We have nice examples here. Very fresh ALDs here along the Dempster Highway. The second one is an ALD that happened after a forest fire in 2023 and caused some destructions in Haggard Creek Road. And finally, we have some huge ALDs that are on the sidewalks of the Donneck River Valley in Crane Ranges in Yukon. And there we go with the retrogressive thaw slump that they occur in permafrost regions due to the thawing of ice-rich permafrost, leading to the collapse and retreat of soil and vegetation. They are ball-shaped depression with steep headwalls that keep expanding as the thawing continues. They can reach up to 1 kilometer in length and can be up to 30 meters in depth. Once they are initiated, they can stay active for many years. Later on, they can stabilize for a while, and then if there are the right conditions, they can activate again. A nice example here, we have an RTS here in Alaska, no, where was that? Yeah, outside from Whitehorse. And here there is a small active layer detachment failure. That photo is from 2021. And then later on, 2025, that happened a bit earlier, of course, the active layer detachment failure transformed into a nice RTS. It's important to say that this is the Alaska Highway. This part now, it's not working. They have traversed the road a bit further. And yes, we go to the objectives of my thesis. So based on these two main landforms, I have created 4 main objectives. So first, I want to quantify the circumpolar distribution of susceptibility of retrogressive thaw slumps. That was Article 1. Second, we still stay in circumpolar scale, but this time I check the regional contrast in the environmental drivers of the retrogressive thaw slope occurrences. And third, we go to the susceptibility of active layer detachment failure this time, and then of course there's spatial overlap with the critical infrastructure as pipelines and roads. And in the end, we leave the physical process of these processes, and then I examine, or I actually have the question, how these thaw-related geomorphic hazards are framed, perceived, and managed with the nature-based tourism contexts. And now we go immediately to the results of these objectives. I will go roughly this the first article for the method, and you can find more details in the article if you scan the QR code. So first we needed, of course, observations. That means retrogressive thunderstorms. And back in 2021-22, I managed to get 19,227 RTSs. And as I'm working with modeling and my model is binary, I needed absences, so I had to map 17,000 of absences across the circumarctic permafrost region. Later on, I collected my environmental factors, climate topology, and soil at 1 kilometer scale, and I used generalized boosting method, GBM, as this one gave us the best results. So we did test random forest, generalized linear methods too, and their sample didn't work very nicely, so it gave us a circumpolar susceptibility map of RTSs. And then here we go now, still the circumactic second objective here. What we did was actually separated the clusters of the retrogressive thunderstorms in 19 different regions across the Arctic, 18 across the Arctic, and 1 from Tibetan Plateau. And what this figure shows exactly is that the hydroclimatic and sediment-related factors vary strongly across the regions, while topography is comparatively consistent. Now we are on the third objective. That was the active layer detachment failures and the infrastructure exposure. Similar as the first article, we go back to collect our observations. This time we stayed only during Alaska, Yukon, and part of Northwestern Territories. So we got 4,000, around 400 active layer detachment failures. This time we decided to go further with the resolution in 250 meters. We used data sets from climate, topography, and soil. And this time I used Maxent as is a present-only method. Well, creates the background data by itself, but that's another story. And then here we are, we have the nice accessibility map, and of course the overlay of the major infrastructure, roads, and pipelines. And in the end, as everything around the processes and infrastructure was done, then we had the question, okay, what's happening if someone who doesn't know what permafrost is, and now the tourism actually has been increased in the Arctic, what's going to happen if they are in the right place, the wrong time, or I don't know about them. That's something that we don't know. So we made an overlay. We used this accessibility map. We overlaid the national parks. This is a regional study only for Yukon area, as we had data from that side. What we will see is that remote areas experience extreme hazards with few visitors, while accessible destinations face moderate hazards but high exposure. This creates new challenges for safety management and risk communication in Arctic regions. So what we should take out from this presentation: thought-driven slope failures are constrained by persistent climatic and ground ice conditions. Susceptibility patterns show strong regional contracts driven primarily by hydroclimatic conditions and sediment properties, while topographic controls are comparatively uniform across permafrost landscapes. And exposure is concentrated where susceptible terrain overlaps with infrastructure and human activity, underscoring the need for integrated risk planning. And I guess that's it. Thank you.
Thank you, Irene, for putting your 3 or 4 year PhD in 10 minutes.
5.
Anyone has a quick question to Irene before we move on? Maybe I have one. Was there one? Yeah, please. Yeah, maybe I have one. Where do you see the biggest threats across the Arctic? the biggest changes?
Well, degradation is happening. So it has more forms than actually retrogressive thaw slump or active layer detachment failures. But this is what I was focused on. So yeah, I think in infrastructure and like in humans, like people who actually live in the Arctic, they're the one who gonna receive the consequences more than us.
Yeah, thank you, Arine. And then we move on to our next talk, which is also given by two speakers. So I ask Tyril Hansen and Alexandra Meyer on the stage. Here they are. Tyril is from the Nordland Research Institute and Alexandra from the Western Norway Research Institute and University of Vienna. There's also a third author I got to know, which will maybe join online. Anastasia Haluniova. And they will talk about the social dimension of permafrost thaw in the Arctic. Please.
Yes, thank you very much. As you just said, our presentation will be about the social dimensions of permafrost thaw in the Arctic. We are a team of early career researchers involved in different permafrost projects. My name is Tiril Hansen, and I'm at Nordland Research Institute.
Yeah, and my name is Alexandra Meyer. I'm at the Western Norway Research Institute and at the University of Vienna. And yeah, Anastasia is with us online, so I hope she hears us and will be probably available for questions afterwards. And we also have a fourth author that couldn't attend, Susa Gatla, also from the University of Vienna and the Austrian Polar Research Institute. So we are all social scientists, kind of the strangers in the room. And this is kind of a preliminary presentation of our reflections, where we try to draw together our research from four very different cases that we will present to you and compare the social dimensions of permafrost thaw across these cases.
So why social science research on permafrost thaw? We argue that the social meanings and lived realities of permafrost thaw remain underexplored. And as social scientists, we therefore ask whether permafrost thaw is actually understood as a problem, and if yes, in what ways is it understood as a problem, and what are the concerns, and how do people actually respond to these problems?
Yeah, and we kind of enter this reflection through the concept of matters of care. I will not go very into detail of this. It's a social science concept, and it kind of urges us to think about how something, for example, permafrost or its thawing, becomes a matter of concern and then maybe a matter of care in certain contexts. And this is also kind of a way to think about how things become important, how they are framed, the narratives surrounding it, and how this may or may not lead to actions.
So let's start with our first case site. This is Barentsburg, located in Svalbard. This is a Russian settlement on Svalbard. They do coal mining there, scientific research, tourism to some degree, and it lives about 300 residents there, so it's a small place, and it's highly transient as well because there are some short-term contracts there.
Yeah, and this is Anastasia's been doing ethnographic research there for a couple of years. And what she found is that in Barentsburg there's actually a fragmented local understanding of permafrost and what permafrost is and what actually causes its thaw and if it's thawing at all. So it's very fragmented pictures. So there are seasonally stationed researchers in Barentsburg, and for them permafrost thaw is a concern, but it's not framed as a very immediate or pressing concern. The residents that live there, they are concerned mainly about like the state of the buildings that they live in. And they care about like this visible deterioration and lack of maintenance, but they mostly do not interpret this as like a consequence of permafrost thaw, but rather as a consequence of lack of maintenance and neglect from the state. Construction workers and state representatives, they work with permafrost and have to kind of deal with the consequences, but they emphasize rather kind of presenting large-scale failures in the present rather than like thinking of it in a more long-term perspective. So to sum up, like the adaptation responses are rather limited and quite ad hoc and improvised. Adaptation in like a longer or larger scale is viewed as infeasible, And there was a permafrost monitoring station that was established in 2016, but the results from this have not yet translated into concrete adaptation measures.
So let's move further till Canada and the Mackenzie Delta and the Beaufort Sea coast. Here, our colleague Susanna finds that the people living here generally has a clear understanding of permafrost and the causes of the thaw. And we see that they express a clear need for more knowledge. People living here, they see permafrost thaw as a concern, and that goes for both the local land users and knowledge holders, because they can actually see the long-term changes. And the same goes for other stakeholders, such as local scientists, government officials, innovators, and constructors as well. And what is special about the Canadian case is that here permafrost is seen as part of the land, which also means that concerns about permafrost thaw are part of care for the land.
People in this region, they're concerned about infrastructure failure, riverbank and coastal erosion. A lot of the infrastructure is located on shorelines. The care or kind of the actions that are triggered by these concerns, they are rooted in a threat to the integrity of the land, as Tiril said, but also to infrastructure and the associated values. And this is also a subsistence economy context. So this is also, their permafrost thaw is often related to concerns related to culture and to health and well-being, but also subsistence, or like really the food also. Responses are here also mostly ad hoc repairs, very like scattered and individual level, but there's also a lot of people trying out innovative building techniques. There is a lot of permafrost research, mainly coming from outside researchers, spending a short amount of time there and not actually being kind of locals, like for example in Longyearbyen. There are big coastline and riverbank protection projects, as well as a lot of communication. And with that, we mean there's a lot of scientists and media or journalists traveling to this region. And in the past years, has been a lot of attention on these problems there. And probably you have heard about relocation efforts also in the Canadian Arctic. And this is locally often seen as kind of just a last resort. So this is not like a wanted option. People want to stay where they live. Not surprisingly.
So let's move to our third and final case site for today. We're going back to Svalbard in Longyearbyen, which you have already heard something about today. Longyearbyen is, of course, a Norwegian settlement. It is highly international and transient as well. It holds about 2,600 residents, currently involved in businesses such as tourism, research, education, and the public sector as well. And in Longyearbyen, permafrost thaw is a concern for residents and experts alike, but they do hold fragmented understandings, and we find that there is no linear association with climate change. Permafrost thaw is understood as a problem, but in different ways. So, for example, we find that permafrost thaw is perceived as an infrastructure problem. It is also understood as a climate change problem, a safety problem related to slides, for example, and also a technical problem, but maybe not so much a political one.
Yeah, and in Longyearbyen, we see that there's a lot of physical adaptation measures to adapt to permafrost thaw. These are mostly directed at the foundation, so to try to stabilize buildings. There's increasing local monitoring, as we have heard earlier today. This is kind of a newer development also to kind of downscale and focus the permafrost research on the more local, like where actually the buildings are standing. And what is special also in Longyearbyen is that adaptation is not seen as a kind of individual challenge, but people living in Longyearbyen are highly transient. They usually don't own their own housing, so adaptation is kind of seen as the responsibility of the company that owns the houses and then ultimately the state.
So across these cases, we see that permafrost thaw comes to matter, and the reason is because people actually live on permafrost, so of course it matters to them in their everyday lives. Yet we also see that permafrost thaw becomes a matter of care in different ways.
And often it's kind of presumed that we know this physical phenomena and this leads automatically to certain actions, but we find, of course, that this is not the case. So a physical phenomenon, in this case permafrost thaw, is perceived very differently in different contexts, and also is responded to very differently. And we also see that the perceptions of permafrost thaw and how it becomes like a matter of concern also determines the actions that are being taken. And we, of course, argue that in these complex relationships where there's no straightforward linear relationship between the problem and the adaptations, we need the social sciences to also understand these complexities. Yeah, thank you very much for your attention. I'm looking forward to questions.
Thank you very much. We have time for a very short, quick question. Yes, Sebastian?
Can you comment on how the economic situation in these different places impacts sort of this short-term versus long-term thinking?
That's a good question. And last year, so at least for the Barentsburg-Longyearbyen comparison, we see that in both cases there's kind of this effort from the state that the settlements should prevail. And that's the same in Longyearbyen as in Barentsburg. It's like a geopolitical aspect to it. But that in Barentsburg there's less resources, and also now Anastasia found that after the Russian sanctions, it has been very challenging to actually keep maintaining and repairing the buildings, where we see that in Longyearbyen there is more willingness and kind of more easy access to national funds to actually adapt. And in the Canadian situation, I can't speak so much for Susanna, but what she has found there is that there are like these kind of punctual, bigger projects, but that the most adaptation is like day to day, and that people kind of repair their driveway and they jank up their cabins and they do it themselves. So they're kind of, it's individual adaptations and they need to use their own funds for it.
Thank you again. And then I think we move on to our last speaker, who will join us online. Tobias, can you hear me? Is he?
Yeah, I can hear you. Can you hear me?
Yes, I can hear you. And we
Great.
have Tobias
Thank you.
Schroeder. He's Associate Professor at the International Arctic Research Center located at the University of Alaska Fairbanks. And if I calculate correctly, it should be 2 o'clock in Fairbanks. Is it correct?
I'm actually in Europe. So
You're in Europe,
I'm on
great.
local time.
That makes it a bit easier.
But could you go ahead and let me share?
Yes. Can you share your screen? Because we
don't
don't
have
have.
sharing
I'm not sure if you
abilities.
have your presentation here. I didn't see it. Let me check with the technical assistance. Now we see you at the
Okay.
screen. That's good.
Hi. I
And
still
now
don't have sharing.
maybe you can share. Tobias will talk about trade-offs and attitudes towards risk when farming on permafrost.
Hmm.
If
Oh, I
you
could just
click
talk
on
about it without any slides.
There's a green button below which says share, and then you just have to find the right.
Yeah. Host disabled participant screen sharing.
On the lower bar in the sentences. He needs
Yeah. No. It's still disabled. Hmm. How much time do I have?
You get your 10 minutes. Don't worry.
Okay. And when worst comes worst, I'm happy to just speak about it.
But could you send your presentation?
I could do that too. What, to Jenny?
Let me ask the technical stuff. Okay, we send you an email address where you can send your presentation in the chat.
Okay. Okay. Did you put it in the chat?
Yeah, just typing right now. Yeah.
Okay.
Sure. Here you go. Did you get it? The email address?
Okay.
Do you want to introduce a little bit about your work, Tobias? Well, yes,
Sure.
maybe you're busy with.
So yes, I can do that while this uploads. So I wanted to present you work that we're doing at the University University of Alaska in Fairbanks. It's an international project that's really working closely with farmers in the Fairbanks area, where we have seen for years, actually many decades, subsidence issues on farmland, and we are approaching this from a very interdisciplinary angle. Let's see. Sorry, I need to focus on getting this sitting there. I think I'm realizing it's a very slow internet connection, so it may take a while to upload. So yeah, we've worked with 10 farmers in the Fairbanks area, and again from a very co-production angle, which is really based on knowledge exchange and co-learning. So it's a 5-year project. Then we have 10 partner farms. They're all located in the Fairbanks area, and what we've focused on was basically the research questions, developed them with farmers together, and looked at the impacts of thawing permafrost on those farmer operations, and how we can mitigate those impacts optimally for the farmers, with the farmers, and also looking at more holistically at the question of farming on permafrost, not only from an economic perspective, but also a social and behavioral perspective, looking at attitudes towards risk and how those can inform mitigation and prevention strategy, and educating farmers more broadly in the Arctic when it comes to having cultivation practices on permafrost. And what we found was really interesting mitigation strategies when it comes to, for example, farm practices. In the north, we're used to extending the farm season with things like mulches, which are basically anything from biodegradable covers to plastic covers in order to extend and warm the soil, keep the moisture in the soil. And we found some interesting, to our research, some interesting trade-offs when it comes to the certain use of mulches, and found some interesting mulches that work better in the permafrost context rather than other mulches. Especially the biodegradable mulches turned out to be very favorable in some of our experimental cases. We also looked at certain varieties. We did variety trials on several partner farms and found that, for example, asparagus grows really well in permafrost affected soil. So, basically offering farmers strategies that they can really use to maximize the land that they, while at the same time that land is affected by permafrost. Permafrost also becomes often a water management issue or a water management project where farmers are starting to grade the landscape and are creating areas where they funnel or basically lead water away from thawing areas so that those thawing areas can dry out and they can be, for example, continue to be used for hay farming. So having various different strategies and various different approaches of using the land most optimally, depending on where permafrost is present and is an issue over time, and adapting that strategy over time seems to be, at least with our research, seems to be a really winning strategy to use to realize some of these impacts, mitigate those impacts, and optimize cultivation practices across available landscapes for farmers. We also found that permafrost can, in the short term, lead to what we call a subsidy. So this means that the thawing permafrost actually provides additional water that can be used for increasing yield. But looking at this from an economic point of view, in the long term, it becomes more costly for the farmer. And this offsets again that water subsidy when, for example, farmers can or have to deal with increasing operating costs related to production delays when they have to regrade certain areas and reseed those certain areas, obviously, time. And also leads to equipment failures by this driving through tractors through subsidence. Cavities open up underneath the surface that are not necessarily realized, and equipment gets lost and equipment breaks more often in those areas. And obviously also reduced yield if that water subsidy that I was just talking about becomes too much and leads to ponding on the landscape. You have effectively less yield coming from those areas, and they also lead, in the extreme case, to field abandonments that we've seen all across the Fairbanks area in certain specific areas where we have very ice-rich permafrost. Entire farms have been abandoned in the past. So these are certainly lessons learned for our farmers and for us as researchers, and we're hoping to really continue this good work to look at mitigation strategies, look at behaviors and attitudes towards risk, especially in formulating new mitigation strategies that are then based on behavior and also based on new technology, just simply through, as I mentioned, through the example of using different types of mulches that are then basically harming the permafrost ecosystem more or less. And so figuring that out and fine-tuning those mitigation strategies based on what type of permafrost you find on your farm is kind of a long-term goal of this project. So I apologize for not being able to show you all this with graphs and nice pictures, and I'm happy to take any questions.
Now it works. Thank
Lost
you.
audio.
Thank you, Tobias.
Okay.
Yeah, and also sorry from our side that it didn't work out, but you made a good, you managed very well to improve. Any questions to Tobias? Yes, please.
I was wondering, the soils are mostly Jedermaß soils, I guess, like the ice-rich organic soils in the region.
So there we have various different types, and I would have shown you our 4 types. Type 1 and 2 are ice poor. and then you have some Jedema soils with very ice-rich, I guess, ice-rich permafrost with big ice lenses. Some of you may have been to our Fairbanks permafrost tunnel, where you can see some of these really big ice networks that are in our soils, and are leading to really drastic landscape changes in the Fairbanks area, especially.
Yes, Sebastian.
Is permafrost degrading everywhere where you have agriculture on these formerly like natural ecosystems, or is there actually places where you have stable permafrost under agriculture soils?
Yes, we have both. We have obviously cultivation practices started in the 1930s with the agricultural experimental farm, also on lands that the University of Alaska Fairbanks has. And there you can see, I would have shown you an old picture from the 1930s where you see those subsidence areas. And in that area right now, you have basically the ice-rich permafrost underneath has melted to the extent that there's no longer really, a problem, and it's not really a problem any longer for cultivation. So we do have, especially in our river valleys now, in the Tanana River Valley, in various regions, we have not as ice-rich permafrost anymore, more like type 1 and 2, very ice-poor permafrost, where we do have farming going on where the operations are not as affected. But then again, we do have areas where farming is affected in a very big way, especially areas that have been just recently been cleared. So maybe in the last 10 to 15 years, those areas, especially on northern aspects, have been really problematic.
We have one more questions by Hanne.
So there's a lot of people who think that it might be an advantage that we are losing some permafrost and that we have warming conditions, and so agriculture would be able to actually expand further north. And I'm really, really keen to hear what you think about that thing.
Yes, so while that issue or that fact was a big motivation for this project and is a big motivation for us to continue this type of research, we see that just simply saying moving agriculture up north is going to be the solution to a warming climate where we lose agricultural areas in regions that are more prone to drought. This is a way more complex issue that we have to deal with. When we move agriculture up north, we need to be more aware. We need to be more aware of the risks and trade-offs that permafrost provides us in our agricultural practices, and that's why I see this type of research is really needed, as that agriculture, the agricultural sector, at least from a North American point of view, in Alaska we have that demand for new farmland. Currently, right now, farmers are looking for land in Alaska to expand their agricultural practices up north. At the same time, we need to start having a better education and better research and science really underpin that movement up north. Otherwise, it has in the past, from a historical perspective, we can say that in Alaska we have tried that before and it failed, that experiment. And what we're saying in our research group is that we need to invest in more research and more knowledge exchange if we want to continue to move that agricultural sector up north.
Thank you, Tobias. I want to open up the floor to questions to all the speakers in both sessions. The first session about more scientific presentations, and second sessions for the social dimension of permafrost threats. So there were some talks where we didn't have time for questions right afterwards. So please feel free to ask questions to any of the talks for the remaining time we have until lunch break. I see one question.
Yeah. Is it possible to still ask a question to Tobias?
Yes, to anyone, so including Tobias.
I was wondering, it relates to the question by Natalie about it being mostly Yedoma and with agricultural soils. The permafrost, at least in the tunnel, has enormous amounts of ammonium and nitrate. So did you look at this in the perspective of mineral fertilizer used by the farmers?
That's interesting. No, we have not. Although we do have, and not somebody on our project, but somebody that's interested in getting more into the soil. We do have a soil scientist on the project, but yet I think expand. It's an interesting question, but I'm coming from a social and economic perspective, so I apologize, I won't be able to answer that question.
Yes, one more question.
This is a question to Christina and Ravna. I hope I pronounce your name correctly. I was wondering if one would want to do that research in another area, how would you get in touch with the local people and what steps did you do? Like, how come that Woodwell does something there and how did you manage to get that collaboration going?
Yeah, so we partnered with the International Center for Reindeer Husbandry, and so they have contacts with reindeer herders all over the Arctic. And so when we made that connection, that collaboration was already sort of there.
Thanks.
More questions? Maybe I have one. I don't know who will be the best. Sebastian, you have the best overview. If I see whenever I see permafrost maps, the largest chunk of permafrost is in Russia. How does the new geopolitical situation, which occurred or is occurring since 22, affecting permafrost research, data availability, collaboration? We cannot do everything remotely, right?
Yeah, so it depends a lot on whether the existing time series are enough or not. So when you have data-driven models, which basically need input, so for example, a lot of the upscaling that is done for carbon fluxes relies on basically getting a new chunk of data every year, and then you can basically make some sort of upscaling for the entire Arctic. That is hugely affected. When you talk more about process models, then quite often we can work for quite a while with what we have. So there it's less affected. So for example, the things that I showed is less affected from the operational standpoint. But of course, there's quite a large chance that, let's say, models start diverging from observations without sort of noticing it. And then this is quite a risk that we're becoming too reliant on models. And not really seeing something that is actually going on. And then the second problem I really think is that there is certain types of permafrost that are almost exclusively occurring in Russia. You can sort of frame this from all sorts of different sides, yeah. So, but you can go to Mongolia, you can go to northern Norway, you can go to places in Alaska and Canada, but it's not going to be exactly the same. Yeah? So this is, for example, these very old areas, so which now, for example, have still cold climates, like in northern Siberia, and some process research basically can't be done elsewhere. And of course, if there is no access, there is a problem of conducting this research.
We have one question here in the front.
I think Tobias was first.
Tobias, do you have a question?
Yeah, I have a question to the second presenter on the Svalbard permafrost mapping.
Please.
How do sediments and permafrost react to extreme rainfall, and how do you know how extreme weather events may change your hazard mapping?
So I think you are asking about the dynamics of the flows that I showed you a little bit. And that's, of course, interesting because I didn't have time to go in detail with the process dynamics. So when you get thicker active layers, and they are typically developed when you come into the autumn, and with climate change you get longer shoulder seasons, typically the autumns. So you have a longer period where you can saturate the ground, and then you can have more detachment, and that's simply physically more mass that can move if you have a longer unfrozen season. This means that the active layer is active for a longer time. I think that was what you asked about, if I understood you correctly.
Thank you. And Cyril?
Yeah, I had a question about the Permafrost internship program. What disciplines are the people or the students coming from, and do you also have any plans to include the social sciences?
Yes, that's a very good question. So all disciplines have been included so far. So yeah, doesn't matter or social science and geoscience. Do you want to?
I just want to add that actually we have been asking for also research projects to want to have students. And we see that because we have these challenges that Julie very nicely presented with actually bringing students into companies. There's so much administrative work on that I think that it's really within moving students within academia is really successful. And I think, just looking at these two sessions, see how interdisciplinary and even transdisciplinary we're actually getting within Permafrost. So I'm thinking that hopefully we manage to keep this service running, and hopefully social scientists also start asking for having students, because when you look at how many students are interested, I'm sure there will be lots and lots of potential. And this is super important because as we can see with the interest, there's a lot of more students that need to learn more about permafrost than what we can offer at the universities at the moment.
Yes, one more question.
Hi, thanks everyone for the great presentations. This is not specifically dedicated to a particular person, but whoever would like to answer. Just curious, based on your experiences, what are the largest scientific gaps that we have right now in our understanding of the permafrost? What do we need more of? Is it better modeling capabilities, more satellites that are put up to the job to understand it better? Or is it more of the local observations that we need more of? What are the biggest gaps?
Who wants to answer this question, please? Hanne.
I can start, but there will be many answers to you. Actually, I think that what you have learned today is that there's a lot of things going on, both in terms of modeling and observing, and observing in many different ways. But what we have touched a little bit upon, both in Sebastian's talk, but also in the GTNP talk, is that we need data to be available much more than storing them in this and this database, and we work on this on our computers and so on. So what we need is to be able to have accessibility, and this is really the next step, if you ask me, so that if you live in an area and you think something is actually affected by permafrost, you have a place where you can go and learn something about what is going on right now. And we can see that also if you're in an area that is undergoing rainstorms and so on, and you're maybe starting to think, okay, what's going on? Then you need this access to data immediately, and also to models like Sebastian showed.
Anyone wants to add anything on it? Sebastian?
Yeah, so I just want to add one point, which is not so much in, let's say, in people's minds, and this is really that we lack a fundamental understanding of some of the processes, just like how the ground freezes. I mean, Hanne showed these pictures from a core and all these different ice types. And of course, we have to some extent, we know roughly what's going on qualitatively for sure. But we don't really have a good model which would be based on largely physics, or at least good parameterizations which would work for all of this. And this is something that's virtually not done. I don't think you have much of a chance to get research money for that, because it's only like, there is like 4 steps in between before that would give us let's say, new global projections of thaw or something like that. This is something where many of the experiments are from the last century, and then somehow it stopped. And interestingly, China is ramping up very strongly on this. This is almost not seen, but like in the last 10 years, there is more and more of these publications. In Japan, there was a lot of research done and still is in this direction. But these things, this is actually like also, especially when it then integrates like carbon, we are still lacking that. We're doing okay with our measurements. Like this is, you have seen, it's not like we don't understand much. Or there's big fundamental gaps, but in order to go on for the next 20 years, I think there's also some fundamental knowledge lacking here.
Thank you. We have one more question, yes.
Yeah, if I may compliment about the mechanistic understanding from an ecologist point of view, there's also very many things that we don't know about the Arctic in terms of what is present in the soil food webs, how many roots grow, where do they grow, how does that change. And I think we only have data that is pretty good for a couple of locations. So that is Abisko, Zackenberg, Tulik. So we need to know a lot more about how these biotic interactions affect carbon cycling and such as well.
Any more questions? Sebastian?
I have a question to Ravna. How is the idea from really the local people about science? Is it like what do they think they could need or benefit? And is this actually happening from your perspective, this type of research?
Thank you for the question. Well, yes, I'm becoming a researcher and studying on reindeer herders' food systems. And I have many colleagues who are indigenous peoples who are doing research. And when it comes to monitoring, I think the local people and, for instance, reindeer herders have the best overview of the land. And, for instance, about the permafrost. When I discuss with reindeer herders, they see in nature, but they are not able to explain why it happens. For instance, with the palsamires falling or being. So yes, I think it's important for the indigenous peoples that research is done so that they can understand what happens in the, for instance, in the soil, but also how it impacts them. So, and how research is seen, like science, it's welcomed, but it must be done after the indigenous peoples, that they need to be participants already from the beginning when it starts, when a project starts, not just you come and ask a lot of questions, then you leave. So there are ethical standards for how to do research in indigenous lands. Thank you.
One last question or comment, yes, please.
Thank you. This is actually for Terrell and Alexandra. I'm wondering in the research if you actually did look at scientific literacy of the different populations you spoke to, and if that was a factor, or do you think that's a factor in the different understandings that you had? You had mentioned that there was a nonlinear association with climate change.
But in Longyearbyen, where I did my research, like we see that there's, what's special in Longyearbyen is that there's a high amount of kind of local experts. So there's like the university center, there's a lot of researchers that are also locals, and this is very unique in the Arctic, also compared to other cases. Science literacy, I would say, in Longyearbyen. But then again, like there's a lot of people, like for example myself also, like before I started actually digging into the literature, and I'm not a natural scientist, I don't understand all the processes. And then you see something, like you hear about permafrost thaw and you know, okay, it's thawing, and then all in the landscape can be attributed to permafrost thaw. And this is kind of what we're looking into a bit as well. Like there's a lot of buildings cracking and landscape changes, and some people say, all of this is permafrost thaw, and then you speak to the engineers and they say, no, it's actually, it's not climate change induced permafrost thaw, it's also the way we build, and so it becomes much more complex when you start digging. So yeah, there is some science literacy, but not everybody knows everything that is going on, including us. Yeah. And that's also maybe something that is, from a social science perspective, it's for us not right or you're wrong. So we're trying more to find out what do people think, and how does that relate to the way they see their world and they act upon the problem. But we're not after like trying to say you're right or you're wrong. Yeah.
Thank you. And before and maybe some sun outside, I want to remind you on our Permafrost posters. It's a poster session from 5:30 to 7, and we have a couple of Permafrost posters where you can continue discussing about permafrost science. With that, I want to thank all of our speakers from both sessions for their contribution, and to all of you for coming and listening and joining these 2 sessions. Thank you.